Well, hello YouTubers, Mike here, welcome back to my channel. Welcome to episode 5 of dealing with the silver-plated wire that a viewer Justin sent me. It's the gift that just keeps on giving. Let me tell you, I just can't quit this stuff, okay? Episode 4 came out just the other day, and it was very popular. A lot of views and a lot of comments. A lot of good comments and suggestions. I like it when I get good comments and suggestions. Okay, I tried 3-9-Deucen's method of removing silver plating, and it did not work worth a darn. And well, I had already come up with some theories on why it didn't work because the stuff he was dealing with had a nickel underplating, and this stuff doesn't. Um, but also, a lot of suggestions came in, and if there's any validity to the wisdom of crowds, then basically they're saying I should need to use less water and do it cold and try it again. So I think we will do that. I think we will try that this time. We will do it. We'll use less water and we'll do it cold. And there's also another video out by a YouTuber called Silverstole. I've been following his channel lately. He's a fairly new YouTuber. He does a lot of interesting stuff with silver, and he has a method for taking off silver plating too that's very similar to what you folks have been suggesting. So we'll try that. But what are we going to try it on? That's the question. Well, my buddy in Montana, Tim Toolman, has come through. He's the fellow with the granulator who I sent the wire off to, and he had a lot of trouble granulating it. But he has a lot of other cool equipment. He's living up to his name, Tim Toolman, let me tell you. He has an automated flour sifter, and he's been running the stuff from the granulator through the sifter. And the granulator couldn't separate the insulation from the wire after chewing up the wire. But his flour sifter can. So let's see what Tim has sent me here. A couple bags of stuff here. And this is, I got to tell you, this is some good looking stuff right here. This is the wire after going through his granulator and then going through his automated flour sifter with a 30 mesh screen, and over here with a 40 mesh screen. Now, I'll tell you what, the 30 mesh screen looks really good. There's still some bits of insulation in there. Yeah, get a good focus on it. But, it's pretty darn good. I mean, for anything I'm going to do it, because I'm not going to melt this stuff. I mean, people keep telling me, melt it, make anodes for a copper cell. Yeah, I know. I see that as way too energy intensive to recover maybe 4% of silver out of this stuff, okay? Because energy equals money. You got to remember that. Propane equals money. Electricity equals money. And there's only 4% of silver here, okay? So I'm not sure it's worth it. I'm not going to melt it. I was thinking about that early on, which is one reason I wanted to get rid of as much of the insulation as possible, because it's Teflon, and you don't want to be exposing Teflon to that much heat, or you're going to make some pretty nasty chemicals. You don't want to be breathing those nasty chemicals. And I don't want to be wandering around here with my gas mask on. The neighbors will, well, have questions, okay? But anyway, yeah, this stuff, especially the 40. The 30 looks good, but the 40 looks amazing. This is almost pure wire. There's still little bits of insulation in there, but not a lot. So basically, we can do anything we want with these, I think. So we're going to repeat the experiment I did in the last video, but we're going to do it a little different, okay? We're going to do less water and cold and see how that goes, okay? And instead of putting in, well, we could try it two different ways. I was going to say, instead of putting in sodium nitrate, we could just add a little bit of straight nitric acid to it, okay? And, concentrated nitric acid, and see how that works. So I suppose we could do side-by-side comparison of those two things. Now, something else that has come up in the comments on that last video is the use of Eco Goldex to work with this stuff. And that's a gold plating stripper. But according to its literature, it will do silver as well. I have never tried using Eco Goldex to strip silver, and I'm kind of reluctant. In fact, I don't know. Whenever I pull out the Eco Goldex, the comments run into things like, "Oh, it's too expensive. I can't get it." It's like, okay, this is interesting, but it doesn't do a thing for me because I can't get it, or it's way too expensive, or whatever. So apparently, it's very hard to get outside of North America, which I can understand. Even I'm in USA, and even it comes from Canada, and the shipping from Canada can be expensive and fraught with a little bit of bureaucracy. So I can see trying to get it on the other side of the world. Yeah, that could be a problem. But if we can't get a good stripping action with just sulfuric acid nitrate, we might try some Eco Goldex. I don't know if it'd be in this video or a future one, just because people are clamoring for it. Although I know it's a case of be careful what you wish for, because if it works really good, half of you out there may decide that it's too expensive or you can't get it. So okay, but we'll try redoing our experiment. Shut up, Blue Jay. We'll try redoing our experiment with just sulfuric acid and nitrates and see where that gets us in this video, okay? Oh, and I almost forgot. Tim Toolman sent a short video of his flour sifter in action sifting this stuff, and he graciously gave me permission to cut it into this video. So let's take a look at that. Very cool. Wish I had one. Okay, let's get on to processing some of this stuff. I think we'll go with the 30 and save the super clean 40 for another project. I'm not sure how much of this stuff I want to use. Let's start out with 100 grams and see how much that fills the beaker up. $64. Because from my earlier testing and earlier videos, I figure this stuff is right about 4% silver. So 100 grams of material, that should produce 4 grams of silver. Okay, so we'll go with 100 grams, I guess. That's a good round number. We'll measure out 2 portions, and we'll do them slightly different and see what works. $102. This is not the world's most sensitive scale, but come on, you. I pulled plenty of material out of there. Too much or too little. There's no in between. We're going to call that 100 grams because you can't decide whether it's 98 or 102. Okay. So, anyway, yeah, I've spread a little bit on the bench top here, but now we've got 2 beakers here that we can try the silver plating extraction with concentrated sulfuric acid and either nitric acid, which we'll do in one, or concentrated sulfuric acid and nitrate salt, which we'll do in the other. Okay? So let's get these in the fume hood and get started. All right, I got our 2 beakers in the fume hood. I'm going to put sort of an arbitrary 200 milliliter amount of concentrated sulfuric acid in there. This is store-bought drain cleaner that's concentrated sulfuric acid. Now, I have a video coming out soon about how I make concentrated sulfuric acid, or how you can make concentrated sulfuric acid if you can't buy it like I can. But I'm going to save that acid for a special project, so we'll use the store-bought stuff for this. And I'm just going to put, like I say, up to about the 200 milliliter level in both beakers. All right, and we're doing this cold. Not that it's actually cold out here, but the hot plate is off. Okay, it's probably 32, 33 out here, headed for a high of well over 35. C, we're talking. And so much of my audience seems to be in the metric world. We're going to get close to 90. All right. Okay, so mix it up a little bit. Both of them. No real reaction yet, which I was not really expecting much of anything to happen at this point. The sulfuric acid's not really going to attack either the silver or the copper terribly vigorously. This one over here, we're going to put some nitric acid on it. Now, I did a little research, and of course, you can believe everything you read on the internet, right? So, it's looking like it takes about a milliliter of concentrated nitric acid to dissolve a gram of silver, a little over a milliliter, maybe 1.2. I'm going to put about 5 milliliters of concentrated nitric acid in here. All right. That should be about 5 milliliters right there. And we'll stir that around. And we'll see what, if anything, happens. There may not be a lot of obvious signs that anything's going on because, well, if we do strip the silver plating off that wire, silver nitrate's transparent, so we may not see much of anything. Okay? So over on this side, I'm going to put a heaping teaspoonful of sodium nitrate in there. Now remember, I'm doing this the way you guys suggested after my last video. You all said do it cold. You all said do it without water or with less water. So that's what I'm doing. And we'll see how it goes. Alright? This is almost a viewer request special. You know? I'm doing it the way you guys say to do it. And I may have to get a stir stick after that because that sodium nitrate is nuts. Dispersing. I'll tell you what, the wire down there has formed like a solid clump too. That's probably not good. Hey, there's something going on over here. There's bubbling going on, and the wire seems to be a whole lot darker in color. Maybe this is actually stripping the silver off. Is anything going on over here? Not yet. Not yet. We'll just let this sit and see if anything happens. But this one, we may actually be stripping the silver plating off because the wire looks like it's changed color. It's looking a lot more coppery. Okay, so we're just going to let these sit for a little while. You know what? I don't know. Maybe they're both working. We're just going to let them sit for a little while. But the wire has definitely lost its silvery luster. It could just be tarnished. Fooled myself into believing this has worked in the past because the wire has just tarnished from the sulfuric acid attacking it. But maybe something's actually going on. So we're going to let this go for a little while. I mean, there's some actual bubbling going on in this one, which, yeah, I can believe because I put concentrated nitric acid in there, but it's really only 68% nitric acid, so a little water went in there. Okay, so the water in the acid is probably helping the acid attack, hopefully just the silver and not the copper. This over here is a lot drier, but I start to see some bubbling in it too. A little bit. So yeah, maybe we got something good going on here. Okay, so we're just going to let this go for a little while, 10, 15, 20 minutes, and see what happens. See if we actually strip the silver off of this wire without dissolving a lot of the copper along the way. All right, it's been, I don't know, 5, 6 minutes, maybe a little longer. We've got some orange fume production in this beaker here. And I'll tell you what, the copper down there is really starting to take on a reddish color. It is no longer silvery. We're starting to get the reddish color over here too. Maybe a slight trace of orange fumes, but I'm sure this is drier than this. There's less water than over here on this side. So the reaction over here, it is happening. There's bubbling, but it just seems to be going slower. But both reactions seem to be happening. So yeah, and I can see a little bit of orange fumage there. Okay, so far there's really not, I couldn't swear in court that either of them is turning sort of green-blue. So maybe we're not dissolving copper. With all this activity, we've got to be dissolving something, so it must be the silver. That's what I'm thinking. All right, so we'll just let this go a little while longer and see what happens. Well, it's been about another 10 minutes, I guess. This one's still going great guns. We got some orange fuming going on in there, some fair bubbling. This one, not much. A little bit of bubbling now and then, no fumes. Yeah, but the copper really looks really red down there in that one. In fact, it looks red in both of them. I've stirred them from time to time just to make sure that all the wire gets in contact with the liquid, because it wants to pack itself pretty tight in the bottom of the beaker. But I think I'm going to let these go until I don't see any more reaction over here, unless this stuff starts turning green-blue, in which case I'll call it then, because I don't want to dissolve a lot of the copper. But so far, it's just sort of off-white, maybe a little yellowish. It's not really looking like we got copper in solution, so that's good. So just gonna let it cook for now, and be back in a few more minutes. All right, it's been a little while longer, and the reaction seems to be slowing down over here anyway. I mean, this one never really got gangbusters, but this one seems to be slowing down. But I'll tell you what, I was just stirring them a bit ago. This one got warm. This one got quite warm. So yeah, some heat was generated over here, but we had a much more vigorous reaction over here too. Heat was generated here, but not nearly as much. But I don't know. Both might have worked. Both might have worked. I don't know. We'll see. I got to contemplate what I'm going to do next. I got to separate the liquid from the copper. I can't just dilute this stuff with water while it's on the copper, or whatever nitric acid is left in these is going to immediately start attacking the copper, and any silver in solution is going to cement out on the copper. So I think what I'm going to have to do is decant off the liquid from each of these into another beaker, and then figure out how to deal with the solutions in them. That should be an interesting conundrum, I'm thinking. So let me give that some thought. I'm just going to let this sit for a little while longer, because it really doesn't look like it's attacking the copper. I just want to make sure, give this stuff a chance to finish dissolving the silver, if that's what it's really doing. Now we'll just let it sit for a little while longer. Maybe I'll go get some lunch, and then we'll decide what to do with this stuff. Well, I went in and had some lunch, and I come back out and I find this. Yeah, something's going on there. We might be getting some copper in solution. I'm not sure. This one doesn't really look any different than when I left. So I think what I need to do is decant off this liquid, stop whatever reaction's going on, and then figure out how to deal with this liquid. And then we'll do this one too, but this one looks like this is the imperative one, because something's going wrong there. I don't think it should be looking like that. So let me get set up to decant this off, glove up, and we'll get to work on that. All right, so let me decant this stuff off. We'll deal with it first since it seems to be going funny. Let's see if I can catch some of this. It's gone purple, which is kind of weird. If I can catch some of this insulation in here. I want to leave the copper behind. Just get the liquid. And I can't rinse this with water, unfortunately, at this point. Not with the copper in there. What I'm going to do is I'm just going to leave this here and let this drain. The copper is looking very coppery, I do have to say. Yeah. So it's looking like we have taken the silver off. I'm just not sure what's going on that's making it all purple down there. Now this one over here is looking very coppery too, but it hasn't gone purple. So I'm just going to let this drain for a little bit until we get this liquid off of the copper, so we get the best chance of getting a good yield on silver if we've got silver in here, and figuring just how much silver we have stripped off the copper. So I'll be back when it's done draining. All right, I think that's about done dripping. Pull this off. Set it aside. Set that aside. Now that I don't have copper there, I should be able to rinse the stuff in here with water. Now there's going to be probably a bit of a reaction because we're adding water to acid. Now it's interesting, we're getting orange fumes. So that tells me that there's still nitric acid in there and it is reacting with something. So there must be some copper that's come over with this, but hopefully we've got all the silver in there. Now this is something you don't normally want to do. I'm going to add water to acid to dilute this. Oh yeah, look at that. Look at that reaction. So yeah, there must be some copper. I'll bet that purple is finely divided copper. I'll bet that's what that is. I'll just bet you. That's what we got going on there. Yeah. Oh, it's turned nice and green. Okay. But the real question is there any silver in there? That's the real question. Clearly we've got some copper, but is there any silver in there? I don't know. We'll set this aside for testing. Ooh, that got really, really hot too, which, yeah, putting water in acid will. And let me find another beaker and we will decant this stuff off and see what we've got going on with it. It didn't turn purple, so things might be a little different with it. All right, same deal with this stuff. I'm going to decant off the liquid. Leave the copper behind. Try and catch as much of the insulation as I can on this sieve. This hasn't turned purple, so we've got somewhat different chemistry going on here between these two. Okay. We'll let this one sit here and drain too for a while until it quits dripping. Then we'll dilute it as well and see what crazy color we come up with or don't come up with. So watching this one drain, it's very possible I got some very small pieces of copper coming over with the liquid. I see what might be some solids coming over. May have had that with the last one too, but couldn't see that because the liquid was such an opaque purple. So we might have a similar reaction when I dilute this, simply because I think we might get some small particles of copper coming down. But this liquid is still, well, sort of a yellow-white, so I don't think we have any copper dissolved in it at this point. And the wire is looking really coppery in there, like we've taken away the silver. So hopefully we've got all the silver down here. I'm going to let it drip a little while longer, and then we'll see. All right, I would say this is pretty much done dripping. I'm going to do exactly the same thing with it that I did with the other one. I'm going to rinse off the stuff in the sieve. Oh yeah, I see some copper in there. So we're probably going to have a very similar reaction here. Yes, look at that. So it's possible we didn't have any real copper in solution until I started diluting this stuff. That's very possible. I'm going to dilute this again, get it to about 300 milliliters like the other one is. Close this just in case it decides to spatter. There'll probably be a fairly strong reaction. Oh yeah, look at that. Wow. I'm thinking we got a good excess of nitric acid in both of these. Oh yeah, certainly this one has a very strong excess of nitric acid in it. But I put a big heaping teaspoonful of sodium nitrate in here. I probably could have put a whole lot less in and got this done with a whole lot less. So there's a lesson learned already. Also, I'm thinking that the other one with the nitric acid, which I put 5 milliliters of nitric acid, it probably could have got by with half that much at the most, because I think we still had a fair amount of nitric acid left in both of these at what looked like the end of the reaction. All right, so we lid this up. Let that, oh yeah, that needs to cool down a bit. The other one got wicked hot too, but let's take a look at what's left in these two beakers after the reaction. Really not a whole lot of difference between them, I have to say. This one seems to have less insulation in it. It must have gone, more of it must have gone into the sieve. This one's got a lot more insulation in it, but the copper looks very coppery in both of them. So, kind of weird on the bottom there. I don't know. What's this one look like on the bottom? I don't know. We'll see. So we'll have to test the two liquids that we've got out and see if they contain silver. Hopefully, all the silver's in them and it's not still hiding in these two somewhere. So we'll see. So these two solutions are in here. They're in the order they were. This was the nitric acid. This was the sodium nitrate. They're both still wicked hot, and they're both putting off orange fumes as they're just sitting here cooling. Had a little bit of a think about this over the last minute or so while I cleaned up my mess a bit. I think when I put the water in, these got really, really hot from diluting the sulfuric acid. And, well, on this case, why we had such a strong reaction with the sodium nitrate was probably most of the sodium nitrate was still in there in the form of sodium nitrate until we added water and heat to it. And then it turned into nitric acid, I'm thinking. So that's probably why we had such a strong reaction with this one. This one, well, I think that purple stuff was probably very fine copper in solution, but it probably wasn't being vigorously attacked by the nitric acid left in here until, again, I put water in, and the water created heat, plus it diluted the sulfuric acid, and the nitric acid was then able to attack that microfine copper. So I'm thinking that's what happened here. I could be wrong. I could be off base. Leave a comment. Let me know what you think. But I'm going to let these cool down a little bit, stop fuming so much before I test them for silver. All right. Besides, I've also got a couple of errands to run. So by the time I get back, these should be cool. Hopefully not so fumy. And we'll check and see if we got any silver in solution and which one looks like it has the most. Okay. All right. So let me go get my errands done, and then we'll do that. All right. Let's test this stuff and see if we have any silver in it. This is the first liquid I decanted off. This is the stuff where we did the nitric acid in it, the 5 milliliters of nitric acid. So I got some tap water here. I'll put some tap water in here. And I just need a splash of muriatic acid in here. There's almost nothing left in this jug, but I might be able to get a few drops. Oh yeah, that's more than enough. All right. Let's get a little bit of this greenish liquid and see. Oh, look at that. Look at that. Oh yeah. That has got a fair amount of silver in it. Excellent. So I would say we have stripped the silver off. That's great. Have we stripped all of it off, though? That's hard to say. But we've definitely got some silver in here. So that's good. So let me clean this out, and we'll reset, and we'll test the other stuff and see if we have silver in it. All right, so here we go again. This is the stuff where I just use a heaping teaspoon of sodium nitrate in with the concentrated sulfuric acid. Oh yeah, I think that's about it for that though. Let's see what we've got here. Boom! Yeah! Alright, so both methods worked. Again, I don't know if we got all the silver out of here. This is looking awfully coppery. Although, kind of strange looking on the bottom. Maybe that not 100% of the silver was removed. But I don't know. It's hard to say just looking at it. But we've got two different methods here. Similar, but slightly differing, that seem to have produced very similar results. Okay, so I guess the next step is to try and get our silver back from these two solutions and measure just how much silver we do get back to see if one or the other works better and about how much silver we got back. So let me think about how to do that. I think the first step is going to be filtering these to get rid of all the insulation bits. There's some sediment on the bottom on both of them, and I'll bet it's just bits of the insulation. And I think the insulation's floating because it's full of air bubbles from the nitrogen dioxide gas that's been produced. But yeah, I think filtering them would be a good first step, and then we'll contemplate how to get the silver out of them and measure it. All right, I want to filter this stuff before I do anything else with it, but I think I need to dilute it some more. I'm going to bring it up to a full liter. Now I'm going to need a little more water. But you're asking, why didn't you filter it before you diluted it? Well, this was still highly acidic, and I was afraid it would just chew right through my filter paper. And, diluting it's got it warm again. I may have to let it cool a bit because hot acidic liquids will destroy filter paper. So I think what I'll do is I will get that up to a full liter, and I will dilute the one that's still in the fume hood over here too, up to a full liter. And then when they cooled a little bit, I will proceed with the filtration because, yeah, that's going to get hot again. It just cooled down to about ambient. Okay, so let me crack open another jug of distilled water, get these diluted all the way, and we'll let them cool a little bit before filtering. All right, I think this is cooled off enough to filter, hopefully without destroying the filter paper. Also diluted it an awful lot, so any luck at all. We'll be able to get it filtered. Nice clean filtrate. Now, I've been thinking about how best to get the silver back out of this stuff. You know, I could convert it to silver chloride and use the lye and sugar method. That's one way. Or I could just throw some copper in here and cement the silver out on the copper and then weigh the amount of cement silver. I'm thinking that might be the way to go. One complication with that problem is I think we got some excess nitric acid in both of these, especially the one where I use this sodium nitrate. So it may take a while before the silver cements out and stays out because it may redissolve again and again and again until enough of the copper dissolves to use up the excess nitric acid. So, but still, I'm thinking that might be the best way to go. It's pretty hands off. I just throw some copper in here, walk away, and come back when the reaction's done and weigh up how much silver there is. So, I think we'll try that way. So, let me get both these solutions filtered, and we'll get some copper in them, and we'll start cementing the silver. All right, so I got our two filtered solutions here. This one over here, the one that had the nitric acid in it. I'll put a coil of copper in it. And this one over here is the one that had the sodium nitrate. Coil of copper in it. And we'll just let those two go and see what happens. Like I said, I have a feeling there's a lot of excess nitric acid in these two, so probably tomorrow or tomorrow afternoon or the next day, probably before the reaction stops, and we'll be able to see how much silver we actually have. We'll see. We'll just let them go and we'll see. So I don't know how well that's showing up, but you see the wire's gotten fatter. So we've got some silver cemented out on both wires, but we have a lot of bubbles attached to the wires too, especially over here on this one. I don't know if they're going to show up, but there's a lot of bubbles on there. I think you can see them. So that tells me that we've got a reaction going on with the residual nitric in there. So until that reaction's done, the silver's just going to grow and then go back into solution, and then grow and then go back into solution. And it'll use up, we got bubbles coming up to the top and popping. Those would be nitrogen dioxide. So that will just keep up until we use up all of the residual nitric acid in there. And then once that's done, the silver will start coming out and staying out. So it could take a while. It could take a day or more. I got a feeling there's a lot of residual nitric acid in here. Oh, a big bubble came up. See that? So this could take a while. But, well, I'm not in a huge hurry. We'll just let it go and see what happens. Probably check in on it again tomorrow because it's getting late in the afternoon. It's getting dark, getting late, but I thought I'd come out and check on this. Wires are getting really fat, but boy, there's a lot of bubbling going on in both of them. And yeah, it's a little orange up there, so it's nitrogen dioxide gas. And yeah, the silver's just redissolving as fast as it's cementing out, but there is a fair amount of silver in there. So we'll see what we got in the morning. Well, it's the next morning, and well, we've got a fair amount of silver on the coils in there. I'll open this up so you get a better view. And again, this is the one I use nitric acid on, and this is the one that I use sodium nitrate on. The sodium nitrate one still has some bubbles, so I'm thinking there's still some excess nitric acid in there that's probably still in the process of being used up. The nitric acid one, it looks pretty much done. But I think I'm just going to let them sit for at least a few more hours, maybe the rest of today. And then maybe this evening, we'll see if we can separate the silver out of here and get a weight it looks like a fair amount of silver, but it always looks like a lot when it's wet. So, you know, the cement silver always has it's a fluffy, high volume stuff while it's wet. Once it's dried out, though, there's usually not that much weight there. But we'll see how much of our roughly 4% of silver in this wire we actually managed to get with this method. And I don't know if I said it earlier, but I am crediting another YouTuber, Silver Stole, with this method of recovering silver from silver-plated copper. Um, I saw this in one of his videos. He was using it to take silver plating off of other items, but I'm just trying it with this silver-plated wire to see how well it works. And so far, it's the best method I've tried. I mean, I could have dissolved all the wire in nitric acid, but that just takes way too much nitric acid, way too expensive. Time consuming, too. This was relatively quick. So, yeah, other than the whole cementation process, which has taken a while. But, yeah. So, yeah, check out Silver Stole's channel if you haven't already. After you finish watching this video, don't go there yet. We still got to figure out just how much silver we've got here and which process works better. All right, so we'll just let this go for a little while until it looks like the reaction is really done. Well, it's a little after midday, and I have shaken these beakers and see how the it doesn't look like silver. It looks like something else nasty, but see how the silver's floating? It's because it's full of gas bubbles, nitrogen dioxide gas bubbles. So I don't know if the bubble production has stopped, if all of the nitric acid has been used up or not. I guess if this floating silver dissolves and goes back into solution and re-cements out on the copper, we'll know it's not done yet. But, you know, if they just sit there and nothing happens, then I guess the reaction is done, and I can decant off the liquid, dry out the silver, and weigh it up. So I'll just wait a few more hours and see what happens. Okay, it's been another day, so whatever reaction's been going on in here is over and done with. All of the nitric acid's going to be used up. So it's time to pull out these coils, shake off the silver, pull out the coils, get all of the silver off of them. Nice shiny copper here. At least till it tarnishes in a little while. All of the silver off of it. Every little bit. Okay. Let's see if I can get all this silver to sink. Get the air bubbles out of it. Bust up these floating silver turd-like things into small pieces. Maybe let the air bubbles out so they can sink. On YouTube. And then I can decant off the liquid, and we can figure out just how much silver we have here. There, that looks like it's all sinking. Good. No more floaters, just sinkers. All right, so let me decant off this liquid. Probably give the silver a couple quick rinses, and then we'll just dry it out and weigh it. I don't think I'm going to bother with trying to clean it up too good at this stage. I just need to get a weight. That's all I need. So let me find something to dump this liquid off in, and we'll get started. All right, here we go. So this is the silver I got using the sulfuric acid and sodium nitrate. I'm really thinking I probably could have got by with about an eighth as much sodium nitrate as I put in this thing. And about half as much nitric acid as I put in that one. Guess you can't believe everything you read on the internet. Imagine that. You can't believe everything you read on the internet. But the source I found about how much nitric acid it takes to dissolve a gram of silver seems to have overstated matters by at least a factor of 2, I would think, by how much leftover nitric acid we had at the end of this process. Stay there. Stay there. I need to weigh you. Don't be coming out. We may lose a few little crumbs. Probably not enough to move my scale once this stuff's dried out. Okay. So here's what I'm going to do, just so you don't have to watch it. This video is getting long. I'm going to give these a few rinses. Well, first I need to empty this into my waste bucket full of iron, and the copper in here will cement out on the iron. And then I'm going to give these a couple rinses each and dump the water off. Then we'll get them in the fume hood on the hot plate to dry out so we can get a weight on them hopefully later today. So, yeah, let me get to work on all that, and we'll be back when I got something to show you. Well, this is kind of interesting. Okay, I've given both of these a few rinses to get the blue liquid off of them. Just rinsed them with distilled water. But look at the difference. I mean, at this stage, it's really hard to determine whether there's a whole lot more silver over here than over here, because this stuff seems to be clumping up and this stuff's staying light and fluffy. So it's possible there's not that much difference in weight between them, but there seems to be a difference in volume between the amount of silver we got. And again, the one on the left here is the one where I use nitric acid, and the one on the right is where I use sodium nitrate. So I'm going to put these in the fume hood. We'll dry them out, and then later today, once they're good and dry, we'll weigh up the powder and see how much we've actually got here. I mean, it looks like there's more over here, but there may not be. So looks can be deceiving at this stage. So let me get them in the fume hood and get them drying out. All right, so there they are in the fume hood, drying out on the hot plates. So we'll let them get good and desiccated there, and then we'll weigh what's left. See what we got. All right, so I guess it's about time to figure out just how much silver we've got here in both of these beakers, and just as I predicted, it shrunk up to almost nothing once it was dried out. So yeah, I don't think we have a huge amount of weight here. Get it all knocked loose from the inside of the beakers. All right, and I'll tell you what, the one with the sodium nitrate still looks like there's less in here now that it's dried up, but I guess we shall just have to weigh it and see what we've actually got. Speaking of which, I guess we'll just start with the sodium nitrate one. We'll weigh it up first. See what we've got. I hope you can see that. Move this out of the way. And let's see just how much we've got here. Well, that's pretty respectable, I have to say. Considered we're looking for probably 4 or just under 4 grams, I would say we got most of the silver out of that wire with a little sodium nitrate in and a little bit of concentrated sulfuric acid. It's a whole lot cheaper method than I was doing it by dissolving it all in nitric acid, because nitric acid is pretty expensive. So 3.39. I had better write that down because I won't remember it, I am sure. Right up here. All right, 3.39 sodium nitrate. Okay, so let me dump this back in the beaker. Swap beakers. And let's look at the stuff we got using nitric acid. And we're zeroed. Okay. Aha. Well, nitric acid, I'll tell you what, it is a wonder drug, nitric acid is, when you're trying to deal with precious metals. It comes in really handy, which is why I'm going to be having another video on how to make it in the not too distant future. So 3.62 grams, so we did a little bit better with the nitric acid. Okay. Didn't get all of the silver, but it's possible I know where it is. Let's go take a quick look at where that silver might be. So I was figuring on getting really close to 4 grams of silver out of each 100 grams of this wire. That's been my experience. So where is the missing a little over half a gram? Well, I'm sure it's still just in here, in these 2 beakers here that have the copper in them still. I wasn't able to rinse the copper because I know what'll happen if I put water in these beakers. There'll be a big cloud of orange fumes will come out, and the copper will start going into solution in the nitric acid residue that's left in there, and whatever silver is left in there will immediately cement back out on the copper. So yeah, I think we reached a point of diminishing returns. I don't think we can get all of the silver out of this stuff without totally dissolving the metal in nitric acid, which is, I don't think, economically viable. Unless you can get your nitric acid for free, or better yet, somebody's paying you to take it away. That doesn't really happen in my world, unfortunately. I have to buy it or make it myself. And like I said, I've got a video coming out on how to make it yourself, so watch for that. But I think we did pretty good. Definitely think we did pretty good. It was a fairly easy process. It was not too expensive. The concentrated sulfuric acid drain cleaner is pretty darn cheap. And I only used a few milliliters of nitric acid. I think I probably could have got by with a lot less. This worked almost as well as the nitric acid, and I just used a little sodium nitrate in it. So I think Silverstol's method is probably the best if you have access to some concentrated nitric acid. If not, do it the modified 3/9 Newson's way we've come up with here. I'm not sure why he used so much water in his video, but apparently no extra water works a whole lot better in my experience. Thanks for suggesting that, guys. That really helped out a lot. So, am I done? Am I done beating my head against this brick wall? Well, probably not, because I've still got all this wire over here that Tim Toolman has been kind enough to run through his granulator for me. So I've got to do something with it to make sure that his efforts weren't in vain. So I think there will probably be more videos on recovering the silver from this wire in the future. Maybe a little while, though, because I'm going out of town for a while. But, yeah, we may revisit this. Maybe I will scale up Silverstol's method here a little more. See if we can try to tune in exactly just how much nitric acid is actually required for this. I put in like 5 milliliters, which isn't much, and I think we probably could have got by with a lot less for the amount of silver recovered. So we might be able to tune that a little bit and scale it up, and maybe recover a serious amount of silver from this wire that I've got left here. So we'll give that a try. So, and what am I going to do with the copper? Well, I think I'm going to put this in my bucket of cement copper that I get from my waste bucket. You know, I keep iron in my waste bucket, and it cements the waste. It cements the copper out of my stock pot waste. So I've got a fair amount of copper accumulated. I will probably just throw this stuff in there, and this will probably eventually be melted down into either ingots and or electrodes for an electrolytic cell. So whatever silver's in here, we may wind up recovering as slimes in the electrolytic cell. So that's a distinct possibility. So subscribe to see those videos in the future. And hey, if you found this video at all interesting, educational, informative, fun, whatever, give it a like, give it a thumbs up, and subscribe to see those future videos. Check out my two other channels, Electric Geek 64 and Mike's Lapidarian Fossils. They're pretty self-explanatory. Electronics and retro computing on Electric Geek 64, and fossil hunting, fossil prep, lapidary stuff on Mike's Lapidarian Fossils. So check those out, and I will see you in the next video. Thanks a lot for watching this one. Bye.